Welcome guys to the networking class. Right, today we will be learning about firewalls. The last time we learned how to build network design using the Cisco packet tracer software on our machines. In our next practicals, we would like to add firewalls to our networks. So we have to know what goes into firewall. When you are being asked what's a firewall, or when someone asks you what's a firewall, or when you are setting up a network design for organization or for an individual, then he asks you what's a firewall, you need to actually let them know what firewall is and its importance in every network system. Basically, the internet as it started, the network as it started normal way, connecting two people, three, four. Later on, realized there were some intruders. People were actually stealing data from networks or getting unauthorized access to networks, paving their way through organization network and taking out information which is meant for high authority in various organizations. People tapping network with all different kind of alien IP addresses. Here comes to the evolution of firewall. A firewall literally means a wall that's preventing spreading fire. So maybe you have a burning bush, you want to prevent it from getting to the other side of the firewall. You set up a wall that will prevent the fire from getting to the other part of the land. So here comes the name firewall. Firewall prevents fire from getting to the other part of the burning land. Now, firewall in networking here, the main purpose here is to help prevent unauthorized intruders in our network. An institution network, organization, individual network. These days we have hackers all around, and what they are seeking for is resources, information that they can use either for personal gains or to bring out a whole lot of conceptions or to blackmail people. So as a network designer and you are designing your network, one of the most important things you will need to consider is a firewall to help you protect your network from intruders. Today we will go in and dive into the various types of firewall, their benefits in network, and then why do we even need them in our various network design. After today's class, on our next class, we will do a practical whereby we will bring in firewall to our network design. Today, you will understand what firewall means first. Basically, there are 5 different types of firewalls. One, we have the packet filtering firewall, we have the circuit level gateway, we have the application level gateway, we have the stateful inspection gateway, and we have the next generation firewall. And with these firewalls, they have so many types how we can even apply them to our network. We will get to the types of how firewalls can be applied to the network. Now, firewalls are traditionally inserted inline across a network connection and look at all the traffic passing through that point. As they do so, they are tasked with telling which network protocol traffic is being and which packets are part of an attack. So as I said earlier, a firewall is able to detect which IP addresses are allowed to pass through or to send packets across an organization network. If not so, anyone with an IP address or with a device can just request or can just join a network and make request from the server. So for example, if you have organization that's on the client server base where the client requests from the server, if you don't have these security protocols, anyone can just tap into the network and request from the server directly without any security measure or without any restriction. By the time you realize the person has gotten what he or she wants. So these are the main works or the different types of works of the firewall. You first target the packet filtering firewall. Packet filtering firewalls operate inline at a junction point where devices such as routers and switches do their work. However, these firewalls don't route packets, rather they compare each packet received to a set of established criteria. Established criteria. So we will look at this established criteria. Example are IP addresses, the IP address we assign, the packet type, the port number, and other relevant criteria. Now our main focus will focus on the IP address, since we are more familiar with the IP addresses in our network design. Last time we assign IP addresses to every device in our network. Now packet filtering, make sure it's actually following the set of rules established by you in a network you've designed. So for example, if you have a packet filtering firewall in your network, its main work is to know or knows the IP address that's supposed to pass a packetry through it. So for example, if an intruder IP address is passing a packet through your network, it will reject it. So this is its main purpose. And one of its advantages is it is very inexpensive, extremely fast and efficient in scanning traffic. Right. Now, this packet filtering firewall also helps in actually minimizing the resource used on a file. So this firewall doesn't actually consume your resources. It actually takes less resources when operating, and it is also user friendly. So you establish or you design your network for individual, for group, for organization. Now when you insert this packet filtering firewall, it makes sure whatever packet that's passing through the firewall is being inspected and it's following the rules you set in that network. So when it finds out, no, this packet person has a very alien rules or rules contrary to what we are having, you actually reject that packet. So that's it for packet filtering firewall. We have circuit level gate. Circuit level gate. Now, using another relatively quick way to identify malicious content is using circuit level gateway. Now, they establish between local and remote hosts to determine whether the session being initiated is legitimate. This is one of the most important sentences we have to take from here. They are established between the local and the remote hosts to determine whether the session being initiated is legitimate. Okay, now let me bring this down. Most groups or most users of a network or most organizations, we have our service being hosted online, that's remote. Then we have a local setup. So let's say we have a headquarters. Then let's say, so for example, let's take Google for example. Google has a headquarters. So headquarters in California. Then they have their data center in Ireland, meaning they access resources through online, so that remotely. So they access their resources remotely from Ireland. Now, this circuit level gateway makes sure that the one coming to fetch the resource from this remote service is actually a legitimate source. In other terms, considered whether the remote system is considered trusted. One, they don't inspect the packets themselves, such as the packet filtering do. No, they don't do that. They make sure the one coming to access that remote source is from a legitimate source or a trusted source or an authorized source. So for example, you set up your server in a different country, or you bought a hosting server in a different country. Now you have your headquarters somewhere. Every day in your transactions, in your dealings, as a group, as an individual, as an organization, you fetch resources from these remote areas. Now, when you fetch resources, you are sending requests to these remote areas. When it gets there, this circuit level gateway is going to verify either you, the one you are sending resource or you are sending request, is legitimate or trusted source to actually take that file out. So most of them, when most of these online service or online service we buy, or online hosting services we buy, when you are accessing, they actually also have a scanning tool, firewall scanning tool, even on the dashboard, that actually scans all this. So most tool gives you let's say a security feature that's about 3 level layers. You will verify whether it's you, one, by the device, by password, but so many things. So by the time you get to a resource on that file, you have actually passed through about 4 to 5 security levels to actually make sure that gateway is a trusted one. Is any question? Right. We have its advantages and its non, and I'll send the page where you can go through its disadvantages and advantages. But let's quickly go through the advantages. It only processes requested transactions. All other traffic is rejected. So it only processes requested transactions in terms when it's verified that okay, you are an authorized personnel to access this resource, it will process and give it to you. Whatever traffic that is coming, either from a hacker, from where, it will actually reject it. And it is easy to set up and manage. It is relatively lower in cost and has but lower user experience, since the end user is actually not linked to that remote server or something. The end user doesn't come in there. It's between the authorized people and the remote, so it doesn't affect any end user. The next one you move to is application level gateway. The application level gateway. Right. Now, this actually is referred to as the proxy firewall. The proxy firewall functions as the only entry point to an exit point from network. So you take the key sentence from here. It functions as the only entry point to an exit from the network. Now, application level gateway filter packets not only according to the service for which they are intended, as specified by the destination port, but also by other characteristics such as the HTTP request string. Now, let's take it literally. When we visit a website, so let's say I want to visit ask.com. Now, when I visit this ask.com, they have a search engine. I input whatever I want to ask, then send it. Now, I've sent a request to ask.com server. This gateway is there to actually check that the entry point and the exit. So it knows that you are coming in with, you want to know what is a verb. So once you are coming, it has scanned you everything, the same entry point, a verb, then you enter. Now when you enter and you are coming out, the HTTP string you sent and its corresponding response, it will get to that entry point and scan it again and make sure you are coming out with the definition of a verb or something relating to a verb. There is no way when you enter and you are coming, you come with something like what's the money, what, so in addition to what's a verb, meaning something went wrong. So it makes sure the entry point and exit point, in fact, tracing the HTTP request string. So it makes sure all requests done on the HTTP follows a certain rule and protocol. So if you're a hacker and you disguise yourself in some way and you enter, now remember when you are coming out is the same entry point you exit. And when it finds out, oh, this is an alien service, or this service is actually kind of different from it, to actually reject and bounce you. Let's take a quick look at its advantages. It examines all communication between sources and devices behind the firewall. So it examines, as I said, above the entry and the exit. So you, the device entering, it examines you, make sure you actually qualifies to enter. Now the sources, when you go and you are coming to, it makes sure that what you are coming, it's actually what you actually requested for. Checking not just the address, port and TCP header information, but the content itself before it lets any traffic pass through the proxy. As I said, before you pass through it, check the HTTP string, the request you send, and what you are bringing out. It provides fine-grained security controls that can, for example, allow access to a website but restrict pages on that site the user can open. So if you realize, I don't know how many of you has actually visited some website, you click on a certain page, it says you are not authorized to enter. This morning I visited the server and I found some resource, but there was some other page I wanted to go, but I think I've closed it. It told me I've actually let me see if I can get, I don't have access to that particular page. I think I've closed the page. I'll share the link in the Slack channel for us to visit it. Now, there are some sites you visit, though you can explore so many things there, but there will be one specific page you click on, it won't open. You are not allowed to access that website. For example, most movie service, Most movie service, when you access a movie server and you download your movie, now after finishing downloading your movie and you try, some servers are very open. So they actually have another link you can actually click on, and if you are lucky, you will land on a whole directory of movies. So movie directory, every movie that has come, they have their download link there. So there are those links they insert in movie websites whereby you go and click on download and you download. So I'm talking about that server behind it. When you are lucky and you get such link, you open and you find a whole lot of movie servers there. Movie links. It's on someone's server. Now, if you are so unlucky, it will only permit you to download. And when you try to actually go beyond that link, it will tell you you can't. Let me try and give some example here. Now we have the fourth one. Say stateful inspection firewall. Now, a state-aware devices not only examine each packet, but also keep track of whether or not that packet is part of an established TCP or other network session. This offers more security than either packet filtering and a whole lot. Okay, the stateful inspection firewall, it checks the main duty here. It checks the IP address and it monitors the entire session of the state of a connection. So for example, you will be there on your network, then all of a sudden it becomes slow, or all of a sudden the bandwidth start to increase, meaning there's something going on, meaning there's an intruder. So this stateful inspection firewall network actually monitors the entire session of the state of the connection while also checking the IP addresses and the payload for more term security. It also offers a high degree of control over what content is let in and out of the network. So it knows whatever is coming to enter that network. If, let's say, we have established a firewall or a network. Now, we have defined the IP addresses, so you realize whilst actually designing our network, we specify each of our devices with an IP address. Now, our network knows, our firewall knows each of the IP address that's required to fetch resources on that network. The moment an outsider IP address starts to get in, it will see it and it won't allow it to enter. So it controls the in and out of a network. And it also monitors the entire state of your network. So the network you are building, then the network is going, so always, so let's say that your speed is 3 megabytes per second. Now, today, it has slowed down to 1.5 megabytes per second. There is something going on. Now, the first thing you go and see, or you go to, is your stateful inspection firewall. It actually helps for you to identify what the state of your network is at and what is going on and what IP addresses are trying to access your resource. Ladies and gentlemen, firewalls are very important, or they are very vital part of every network we build. No matter what network you are using for, firewall is very essential and you need firewall in every network. Your resources could be very vulnerable. Maybe you might know no one will get this link, By the time you realize, someone is also using it somewhere without even your notice. And these hackers, they are so intelligent that they won't cause the harm in one day. So they will be using it with you, you would never know. Until years back, you identify, oh, so this was happening. So firewall is very important even from the onset of our network establishment. Now, the next thing we will move on is firewall delivery methods. How is even firewall delivered? Is it a software? Is it a hardware? How is it even delivered? Or how can it be applied on our various network? We will do it very quick so that we can end the session. Now we have hardware-based firewalls. When we talk about hardware-based firewalls, these are the appliances that set as a gateway between devices inside the network perimeter and those outside it. Because they are self-contained appliances, hardware-based firewalls don't consume processing power or other resources of the host devices. So hardware-based firewalls, they are actually set inside our network perimeter. So, for example, we have a hardware-based firewall whereby you set in your organization, whereby an intruder trying to penetrate the hardware base will block it. Now we have the software based. Now the software base is actually some of the firewalls we know on our various machines, PCs, antivirus devices. For example, McAfee firewall, antivirus or firewall. We have the Windows even as the Windows security firewall. Those are the software base that helps preventing these intruders. We have so if you want to know, you can go to your, if you are those using Windows, you can go to your settings, can click on the Windows key plus the letter I. Go to the settings, then you click on the Windows firewall. Yes, Windows security firewall. There will be a firewall. So when you click on it, you see firewall network firewall. So all those networks, all those firewalls will be listed there. So all those are also protecting you from intruder, from getting access to whatever network. Your computer is a network. So if your computer is not protected, maybe you might think your computer is not a network, no one can. But the moment your computer is connected to the internet, you are vulnerable. Anyone can access every resource on your computer. So I'm here, I've connected. The moment I connect, so I've connected I've made an internet connection. I'm searching on Google. The moment I connect my device to the internet, you are vulnerable to any attack. It means you are outside, you are on the globe. You are also exploring the globe, the internet. Someone's computer you've gone to. So someone too can also come to your internet. It's very simple. So we need firewalls to protect us in every aspect. Now, one major advice I'll give to us, each of us, is when you are not using your internet, kindly switch them off. So for example, maybe you are sleeping, your data you are not using, kindly put it off. It's advisable to put your unused internet connection off, because if you put it on and you are not using it, someone might, and maybe you are not even having firewall protecting it, someone might find you on the internet, your IP address is open because you're connected, and try to actually attack you whilst you are asleep. You might not notice. By the time you realize you've been attacked and all your resources or have been taken or have been had access to. So it's advisable when you are not using your internet, you switch it off. Whenever you need it, you switch it on, you go to the web and make sure you are protected by a firewall. We have so many types of firewalls on the internet. You can download them. Some are paid, some are free. Yes. So I'll send you some links of the free ones. You can download them and make sure you are protected. We have cloud or hosted firewalls. These are served on this service. So for example, for those who actually have their resources on remotes. They apply these firewalls so that unauthorized entries won't be permitted, and also your resources will be in secured hands for your own safety. Ladies and gentlemen, this is all about firewall we need to know for today. Our next meeting, we will try and apply firewall to our network design in our Cisco packet tracer, and we take it from there. Any question? Right. If there are no questions, thank you very much for joining today's class. Enjoy the rest of the day.